Hi everyone, I am Shubham Garg and welcome back to the lecture series of Tana. So in today's video we are going to see how to generate a symbol of a schematic. Okay, so here on my screen I have the inverter schematic which we have seen in the previous videos. Alright, so now you see whenever we are making a circuit, we cannot always use the same circuit in a complex circuit designs. Let's say for example we are making some kind of gate or something, we are making an adder, we are making an arithmetic logical unit or anything. We cannot use inverter and gates like these circuits. These will be very complicated and won't be easy to read. So what we will do is we will generate a symbol out of these so that we can use those symbols in bigger circuits. Alright, so I'm going to show you how to generate a symbol of this inverter first of all. Alright, so for that I'm going to remove all these sources. Alright, all these probes. Now here this is our final schematic. I'm going to save it, and now we are going to generate the symbol of the schematic. Alright, you can do one thing, you can remove the power sources as well, and you can supply the power sources when your symbol is created, or else you can leave the power sources right now, and there will be no need to attach the power sources again when the symbol is created. So I'm going to leave the power sources right now, and here I need to go to cell, and here is the option that is generate symbols. So I'm going to click generate symbols, and we are not going to change any option here. So I'm going to click on replace. Alright, so you can see here this is this kind of thing is your symbol. Okay, but first of all let me tell you, you can't use this symbol directly. If you try to move it, the parts will get distorted. Alright, so what you need to do is just save this. Alright, and you can see here when you go to here in the inverter, you have two things now, that before you have the schematic and now you have the symbol as well. Alright, so what you can do is you need to create cell and new view, and you can name it as let's say cell 0, I name it as SYM. Okay, view type, change the view type as schematic. Alright, so you are creating a new cell for the schematic. Now here you have a new cell. So here what you can do, you need to go to your inverter library or whatever library name you have chosen, and now go to symbols, or you can go to all. You can see view type symbol here. So just you need to create an instance like you always do for all the other components. So just create an instance, and you can see we are able to move this symbol here. Alright, so here is the symbol. Let me just zoom. You can see here this is the A, that is the input, this is Y is the output, this is ground and VDD. Alright, so what I will do, I will just use the input port, and I'm going to paste it here. I will name it as A. Similarly, the output port, I will name it as Y, and then there is ground and VDD. Alright, so here I'm going to go to ground. So I'm going to create an instance. Here is this ground, and finally there is VDD. Yeah, so let me just add VDD here. So I'm going to create an instance, and here is our VDD. Okay, so now you see we don't have to include the sources for VDD and input, because we already have that in our schematic when we created the symbol. So our symbol basically already contains those sources. Alright, so this is our symbol. Now let's when we double click the symbol, you can see this is the schematic of our symbol. Alright, that is, these sources are already present, so we don't need to add the sources again. So here is our symbol. Now let us do one thing. Let's run the symbol, let's simulate it. So here is the start simulation button. So first of all, let's set up the simulation, see if yeah, you can see we need to give the options again. So I'm going to give the stop time as 100 nanoseconds, maximum step time, let's say 1 nanosecond. All right, initial conditions, we are going to leave everything as it is. And now here we need to include the library files. Okay, it is in documents, Tanner EDA, Tanner tools, process, Generic 250 models, and here it is our library file. And don't forget to add space capital TT here. Okay, so yeah, so let's just save it, and now let's just run the simulation. Everything seems fine till now. Okay, so it is showing that simulation is complete, and it is okay. It won't be able to generate the waveform because we did not attach the probes. Okay, that was my bad. Alright, so let's close this. First of all, let's attach the probes. You see, if we have left the probes as it is in the schematic, we would have seen the waveform here, but we have removed that. Okay, so let's just search for voltage print, and I am going to attach one instance here like this, and another instance here like this. Alright, so here now we are going to run our schematic again. We are going to simulate our schematic again. So here you can see, now we are able to see the waveform, and here you can see there is the inverter waveform, that is when the input is 1, the output is 0. Okay, so this is how an inverter works, and this is how we can generate the symbol using Tanner SAD. Alright, so this is all for this video. In the next videos we are going to create some symbols of some basic logic gates. Okay, and then we are going to use those symbols to create some circuits like flip-flops or other latches, etc. Alright, then we will be creating the symbols of those flip-flops and latches, and we will be using them to create more complex circuits like shift registers and all. Alright, so this is all for this video. See you guys in the next video.